Figure 1 shows a sketch of part of the graph of y equals g of x, where g of x is equal to 3 plus the square root of x plus 2, where x has to be greater than or equal to minus 2. Part A, state the range of g. So the range is the set of y values that the function can possibly be. So the smallest the y value can be is the y value here. And then we can see that the y value gets bigger and bigger and bigger and bigger. The y seems to be going up and up and up and up. It doesn't seem to have any limits to that, it just keeps going up and up and up. So I don't think it has an upper limit to the range. All I want to know is what's the y value, the smallest it can be. Well, I know at this point x is minus 2. I was told that x is greater than or equal to minus 2. So if I substitute minus 2 into the function, then I get the square root of minus 2 plus 2. So the square root of 0 is 0. So the y value is 3. So the range is that g of x is greater than or equal. It can equal 3 because x can equal minus 2. So that's my answer for part A. Part B. Find g inverse of x and state its domain. So first of all, I'm going to write it as y equals 3 plus the square root of x plus 2. And remember that the g inverse function flips the x and the y. So I'm going to swap the x and the y around. Now I'm going to make the y the subject. So I'm going to subtract the 3 from both sides. I'm going to square both sides. And then I'm going to subtract the 2 from both sides. So my g inverse function is equal to x minus 3 squared minus 2. I need to state its domain. And I remember that the inverse function flips the domain and the range around. It swaps the x and the y around. So the domain of my inverse will be the same as the range of the original function. So I can just say that x is greater than or equal to 3. Just copying my answer from part A, but with an x for the domain instead of the range. Part C. Find the exact value of x for which the g of x function equals x. So let's take my g of x function, the 3 plus the square root of x plus 2, and make it equal to x. My g of x function equals x. And we're going to solve this. So we'll take the 3 away from both sides. We are then going to square both sides. Expand the brackets. Move all the x's onto one side. And then if we solve that quadratic with either the quadratic formula or your calculator, we find that x is going to equal either 7 plus or minus root 21 over 2. But we need to think a little bit more about that because we've got 2 answers there and there will only be one answer. Because when we draw the graph, so we've already got the g of x graph drawn on my set of axes here. If I draw the y equals x graph on here as well, there is only going to be one solution here. So this is going to be the 7 plus root 21 over 2, not the 7 minus root 21 over 2. So we're only going to give that answer, we're not going to give the minus answer. Next, the other way you can do that, the other way you can check is by substituting it into the original function. If you substitute 7 minus, so if we did 3 plus the square root of 7 minus root 21 over 2 plus 2. So if you substitute the 7 minus root 21 over 2 into the g of x function, you'll find that you do not get the 7 minus root 21 over 2. So that's how we know that the 7 minus root 21 over 2 is not a solution to this equation. Part D. Hence states the value of a for which g of a equals g inverse of a. 1 mark. Notice it's a hence. It's actually going to be the exact same answer to what we just wrote down in part C. It's going to be 7 plus root 21 over 2. The reason why it's going to be that is solving the equation g of a equals g inverse of a is exactly the same as solving this equation here. Because g inverse of a, if I drew that on the graph, remember the inverse function is a reflection in the line y equals x. So if I take the original function and reflect it in the line y equals x, I end up getting something like this. Notice how it's going through the same point here. The original function and the inverse function will always intersect on the line y equals x. So this equation is always going to be the same as this equation, so we can just copy down our answer from before.